All right, good morning, guys. My algebra students. I know that Mr. Ruggieri worked with you guys yesterday on this objective, but I think it'd be cool if I'm able to create a little video lesson for you guys, and you guys can follow along. And hopefully, if I'm able to explain this to you guys a little bit, it might make a little bit more sense, if it's coming from me. So, I'll do my best from home. Okay. Now the objective today, we want to be able to find solutions to systems of equation, and we want to use substitution, right? And that's just one method that we're going to be able to find a solution to a system. We used graphing the last few days, but graphing has its limitations, right? Because the solution to the system has to be an integer value for x, and it has to be an integer value for y. If we do not have an integer value for x and an integer value for y, we're not going to be able to see an exact intersection point of the two lines, so how do we interpret the solution? So we're going to need some other method here, okay? And substitution offers us that opportunity. So step number one when we're substituting is to write the equation using one variable. Okay, now what exactly does that mean? Well, it means since this y is the same as x plus 7, it means that we can then replace this y with x plus 7. Here's the resulting equation. X plus 7 is going to be equal to negative 4x plus 8. I simply replace this y with x plus 7. Now I get a nice multi-step equation. We have variables on both sides of the equation. We want to remove the variable with the smaller coefficient. Negative 4 is smaller than positive 1, so if I want to make this negative 4x into a 0, I'd have to add 4x. And if I add 4x to one side of the equation, my addition property of equality says that I must add 4x to both sides of the equation. Negative 4x and positive 4x, they're going to cancel each other out. That's going to be 0. That's on the right side of the equation. On the right side of the equation, I'm left with positive 8. On the left side of the equation, though, I have 1x plus 4x is going to be 5x. I still have my plus 7. So now I have a nice two-step equation. Hopefully we're all comfortable solving two-step equations at this point. We subtract 7 from both sides of the equation. My subtraction property of equality, that becomes 0. I'm left with 5x. It's going to be equal to 1. And then to solve this equation for x, I'm going to divide by 5 on both sides of the equation. I get x is equal to 1/5. All right. When I follow my steps here, I just solved the equation for x. So that was step 2. Step number 1, we substitute. Step number 2, solve for x. When I continue, step number 3 says to replace x in either equation and evaluate for y. Well, let me change colors here so this stands out a little bit. I'll use red. If x is the same as 1/5, I can once again use substitution in one of these equations to solve the equation for y. When I replace this x with the x that I just found here, I get the following equation. Scroll that up a little bit. I get y is going to be equal to whatever x is, and that's 1/5, plus 7. So we get y is equal to 7 1/5. Now wait a second, Mr. Pilati. You're telling me that x is 1/5 and y is 7 1/5? That would have been really tricky to see if we graphed both of these equations and we were looking for an intersection point. Right? That would be really tough to read. But notice step number 4 says to check it. And I'm always telling you guys, check your equations. Check your equations. So let's check it. My value for x and my value for y has to make both equations true. Okay? So let's replace x and y in the first equation, see if it works, because we know it already works in the second equation. So when I replace y with 7 1/5, is that going to be the same as negative 4 times my x, which is 1/5, plus 8? Is 7 1/5 the same as negative 4 times 5 is negative 4/5, Negative 4/5 plus 8. Is that true? Yes, it is. All right? So that's what we're going to be doing. Those are the steps. We substitute, we solve, we replace, and we check. Okay? Here's our second example. Same type of problem. All right? I'll let you guys stop the video for a moment. All right? So I'd ask Mr. Ruggieri to stop it here. Right? And you guys try this problem on your own. Do the same thing I just did for that first problem, right? Use it as your example. Hopefully you wrote it down in your notebooks. Okay, so let's stop the video here, and we'll pick it up in a minute. Okay, so let's continue. Hopefully your first step was your substitution step. So you're going to replace y with 2x plus 2. Here's my resulting equation. 2x plus 2 is going to be equal to negative 3x plus 4. Hopefully you recognize that we have variables on both sides of the equation. I want to remove the variable with the smaller coefficient. Negative 3 has a smaller coefficient than positive 2. So I'd want to add 3x to both sides of this equation. We get 5x. I get plus 2. That's going to be equal to, well, that's now 0. So I have 4 on the right side of the equation. Nice simple two-step equation. Subtract 2. Subtract 2 from both sides of the equation. I wind up with 5x is going to be equal to 2. Divide by 5 on both sides of the equation. X is 2/5. Well, if x is 2/5 and I still want to find y, I have to substitute and replace. So I'm going to replace in either one of these two equations. I'll use that first equation to find y. Y is going to be equal to 2 times whatever x is, 2/5, plus 2. Y is going to be equal to 2 times 2 is 4. So this becomes 4/5 plus 2. Y is going to be equal to 2 and 4/5. Once again, it's kind of a crazy answer, right? But let's see if it checks. We already know that it works for this equation because this equation we use to find y. So I know 2 and 4/5 is the same as 2 times 4/5 plus 2. But we have to check it in the first equation. So I'm going to do my check over here. All right, so here's my check. I replace y with 2 and 4/5. I want to know, is that the same as negative 3 times 2/5 plus 4? Is 2 and 4/5 the same as negative 3 times positive 2? That's negative 6 over 5 plus 4. Is 2 and 4/5 the same as negative 1 and 1/5 plus 4? Yes, it is. All right, that's how we check it. Okay. All right, we're going to move on to our next problem. Let's see. Can you do this one on your own? This one's real simple. All right, but it's in a different form. So if you want to stop the video, you could stop the video and let the kids try it. See if they were able to do it. If not, we'll continue. Okay. So if you stop the video now, stop it. Okay, let's pick up this problem. I see that y is the same as 2x, so I can replace this y with 2x. This equation becomes 7x minus y, 7x minus, made a little mistake there. We just replaced y with 2x, so this becomes 7x minus 2x is equal to 15. Doesn't get much easier than that. We have like terms. 7x minus 2x is 5x. That's going to be equal to 15. We divide by 5 on both sides of the equation. X is going to be equal to 3. If x is equal to 3, I wish they were all this easy. I'm going to replace x with 3. I can use either one of these equations, but I think you guys recognize that this first equation is already set up for us to find out what y is. Y is going to be the same as 2 times whatever x is. I could use this second equation, but it would be a lot tougher for us to find y, right? We could do it. It would work if our math is correct, but why make things more difficult than they have to be? So I'm going to use that first equation. Y is 2 times whatever x is. We're saying x is 3. Y is going to be 6. I want to check, so I have to check with that second equation. Do my check down here. I get 7 times, oops, no mistake. I get 7 times whatever x is 3, minus whatever y is. And is that equal to 15? Is 21 minus 6 equal to 15? Yes, it is. Right? You have to check your answers. Right? By checking your answers, you're going to know if you're right or if you're wrong. Let's move on to example 4. Oh, this one's a little tougher. Right? It's not set up right now to use substitution. We could do it, but it's a little tougher. But I have to recognize that it's always nice if I have at least one of my equation in the form of y equals. If I look at this second equation carefully, I can rewrite this equation very easily so that it's in the form of y is equal to. Okay? What would that one step be? If we add 6x to both sides of this equation, I'm going to be able to write this equation in the form of y equals. What's the result? Y equals 6x minus 7. Now, if you wanted to, could you have written it as y is equal to negative 7 plus 6x? Absolutely. Right? But I'm going to write it this way. And once I write it this way, I can now use my substitution. I'm going to replace this y with 6x minus 7. So what happens, use this up here, that top equation becomes 3 parentheses. I'm replacing this y now with 6x minus 7. It's going to look like this. I'm going to add the 2x. That's going to be equal to 4. And now you just have, a regular equation with one variable, and you just want to solve this equation for x. All right, you guys should know the steps. Distributive property, 3 times 6x, 18x. 3 times 7, 21. Recopy the 2x, we copy the equals, and we copy the 4. Like terms, 18x and 2x. It's 20x. It's minus 21. It's going to be equal to 4. I have my two-step equation. I'm going to add 21. Oops. That's 22, not 21, Mr. P. I'm going to add 21. Both sides of that equation. I wound up with 20x is going to be equal to, what's that, 4 and 21? That's 25. One-step equation. Divide both sides of the equation by 20. X is equal to 1 and 5/20, which simplifies to 1 and what? 1/4. Now, I want to find y. I have this y here. I'm going to replace that x with 1 and 1/4. Y is going to be equal to 6 times, I'm going to write it in fraction form just to make my life a little bit easier. 1 and 1/4 would be the same as 5 over 4. So 6 times 5 over 4 minus 7. Y is equal to 30 over 4 minus 7. Y is equal to 30 over 4 is what? 7 times 4 7 times 4 is 28. So what's that? 7 and 2/4. 7 and 2/4 would simplify to 7.5 minus 7. So y should be equal to 1/2. Now, this is going to be a bear to check, right? It's going to be a pain in the butt. But you guys are algebra students. You can do that stuff. So, let's do it. I know that it's going to work already with the first equation, or with the second equation, because that's what we'd use to find y. It's got to work for this first equation. So this is going to be 3 times whatever y is, that's 1/2, plus 2 times whatever x is 5/4, that's got to be equal to 4. I sure hope it does. 3 times 1 is 3 over 2, plus 2 times 5 is 10. That's 10 over 4. 3 over 2 is the same as 6 over 4, so I get 6 over 4 plus 10 over 4. What's that, guys? Does that equal 4? It sure does. We get 6 plus 10. That's 16 over 4 equals 4. Nice check. Good job. All right. We have a couple more to do. I'd probably ask Mr. Ruggieri to stop the video here and let you guys try this. I'd give you a little hint. I would take this second equation and rewrite it in the form of y equals, right? So if we rewrite this in the form of y equals, we'd have to do 2 steps. I'd have to add y to both sides of the equation. I'd get y plus 3 is going to be equal to 2x, right? Because that's going to be 0. Then I'd subtract 3 from both sides of the equation. I get y is equal to 2x minus 3. Now, I know that's a pain in the butt, but hey, guys, we're algebra students. And as algebra students, we have to be able to do this kind of stuff, right? We have to recognize that that second equation is a couple steps away from slope-intercept form, or the form of y equals. I put it in the form of y equals. Now I'm ready to substitute. So if Mr. Ruggieri wants to stop the video, he could do it. All right, I'll pause for a moment, and then I'll pick up with the solution. All right, let's go with the solution. We solve for y. I'm going to replace y with 2x minus 3. This becomes 6 times 2x minus 3 plus 8 times x. It's going to be equal to 28. We have the distributive property. I get 6 times 2x. It's 12x. 6 times 3. That's 18. Plus 8x. It's going to be equal to 28. I want to use my solving equation ability. Add my like terms. 12x and 8x. I get 20x. Minus 18. It's going to be 28. Solve this equation for x. Have to add 18 to both sides of the equation. I'm really wishing at this point I picked some easier equations to do, because these are all a pain in the butt to check. But they really illustrate why we can't use graphing. Because if we were trying to find solutions graphing these things, it'd be impossible to tell because of the intersection points. So you have to be able to use algebra. This becomes 0. We're left with 20x is going to be equal to 28 and 18. That's what? 46. Divide by 20. Divide by 20. We should get x is equal to, what's that? 2 3/10. When we simplify that, right? Because that's going to be 40. That's going to be 20 goes into 40 2 times with 6 left over. 6 over 20 reduces to 3 over 10. I'm going to substitute to find y. Y is equal to 2 times whatever x is. Now x in simplest form would be what? 23 over 10. minus 3. Y is going to be equal to 46 over 10 minus 3. Y is equal to, what's that, 4 and 3/10 minus 3. So 4 and 3/10 minus 3 should be 1 and 3/10. Man, let's check it. I know that it already works for which equation? The second equation, because I used that second equation to find y. So let's see if we can get it to work in that first equation. Oh my goodness, this is going to be a real pain in the butt to check. But we can do it. All right, let's see if this checks. Let's come down here. I get 6 times whatever y is. Y is 1 and 3/10 plus 8 times whatever x is. X is 2 and 3/10. All of that has to be equal to 28. Holy cow. Let's do this. This becomes 6 times 10 times 1 is 10. 10 and 3 is 13 over 10. Plus 8 times 10 times 2 is 20. 20 plus 3 is 23 over 10. That's got to be equal to 28. Holy cow. Let's do this. 6 times 13, that's 60, and 6 times 3 is 18, so that's 78 over 10, plus, what's that going to be? That's going to be 8 times 20 is 160, 8 times 3 is 24, so that's 184 over 10. Wow. 184 and 78. I'll do that over here. It's kind of late. Doing this about 11 o'clock at night. So my mental math abilities aren't what they should be. 4 and 8 is 12. 2 carry the 1. 8 and 8 is 16. 6 carry the 1. We get 262 over 10. Something's not right. Because 262 over 10 does not equal 28. Alright, let's see if we can find a mistake. Let me pause the recording and see if I could find it. Alright guys, after a little studying I found our mistake, but that's why we check our work. Alright, I don't know if any of you saw the mistake, but the mistake is right here. Alright, 46 over 10 would reduce not to 1 and 3/10, but to 1 and 6/10. Alright, so that's where our mistake would be. So if that's 1 and 6/10 instead of 1, let's correct this, our check, let's do that. And oh, and I found the, right, because y and x, right, that was right. Okay, so this would be 6/10, and then this should be 10 times 1 is 10 plus 6, that should be 16 over 10. 6 times 10 is 60. 6 times 6 is 36. 60 and 36, that's 96 over 10. 96 plus 84, click. 96 plus 84 is going to give me what? 280 over 10. Right, 96, because that's 96 and 84. 280 over 10, and there is our 28. Wow. This is too much to be doing 11 o'clock at night. But, you know, it's a really good example of, you know, why we check our work, you know, why we check our math. It's so easy to make a little mistake, right? It's very easy to do that, right? But let's keep working. We have a couple more to do. Hopefully you guys are hanging in there and, you know, trying to keep track and pay attention. But, you know, you guys can get this. You know, we just got to keep working together. You know, I'll do my best to, you know, do the video lessons with you. And, you know, hopefully we'll be in contact and talk. And, you know, we'll figure out a way to get this done. All right? So let's take a look at number 6. Might be a good time to stop the video. You know, so if you want to pause it, stop it, you know, go ahead. Mr. Jerry, let the kids work on it. All right, I'll go ahead and do it. This first equation, I want to rewrite in the form of y equals. I'm one step away, so y is going to be equal to 2x minus 1. I substitute. I want to replace y with 2x minus 1. That equation becomes 4x plus 2 parentheses, 2x minus 1. That's going to be equal to 12. I distribute. We get 4x. 2 times 2x. 4x. 2 times 1 is 2. That's going to be equal to 12. Like terms, 4x and 4x. 8x minus 2 is 12. I'm adding 2 to both sides of the equation. I wind up with 8x is going to be equal to 14. Divide by 8, divide by 8. X is equal to 1 and what's that? 6/8, so that's 1 3/4 or 1.75. I want to substitute. Boo boo. Y is going to be equal to 2 times whatever x is, and x is, what's that, 7/4 minus 1. Y is going to be equal to 2 times 7 is 14. 14 over 4 minus 1. Y is going to be equal to, what's 14 over 4? 3 times 4 is 12. So what's that, 3.5? 3.5 minus 1. So y is going to be equal to 2.5 or 2.5. Let's check it. I know it works for the first equation, so let's check using the second equation. And once again, hopefully you understand, I know that it works in the first equation because it's the first equation that I use to find y, right? It's a derivative or a different form of that first equation that I use to find y. So I know it's going to work for that equation, but I have to check that second equation. So I'm going to replace x with 1 3/4. So that's 4 times 1 is 4 plus 3. So that's 4 times 7/4. Plus 2 times, what's that? 5 over 2 is 2.5. That better be equal to 12. 4 times 7 is 28. So we get 28 over 4 plus 2 times 2 is 4. I'm sorry, did that wrong. 2 times 5 is 10. That's 10 over 2. So we get 28 over 4 plus 20 over 4. We get 48 over 4, which does equal 12. Check it out. All right, just a couple more to do. If you want to stop, you could, but you probably don't want to stop it here because these are different. All right. So let me just try to get through these. I see time's running out. We're at 28 minutes already. That's almost a whole period. Holy cow, Mr. P. This first equation, y equals, this would be 6 minus x. Let's replace. I'm going to replace y, boop boop, with 6 minus x. So this becomes 5x plus 5 parentheses. 6 minus x. It's going to be equal to 10. Distributive property. 5x plus 5 times 6 is 30 minus 5x. That's going to be equal to 10. Something happens here. When we combine our like terms, positive 5x and negative 5x, that's 0. So I get this equation. 30 is equal to 10. That can never happen, that 30 is equal to 10. So that is an example of no solutions. When the variable eliminates and we get an equation that is not true, you guys remember those equations from a few months ago, that's an example of no solutions. Kids usually like those because it's a lot less work to do those. A lot easier. And let's do our last example, number 8. I rewrite this equation. This equation in slope-intercept form, or in the form of y equals, would be y is equal to, let's see, if I add y to both sides, then I'd add 2 to both sides, so that would be 3x plus 2 is going to be equal to y. Oh, look what I see. I see we get the same equation. Y is equal to 3x plus 2, y is equal to 3x plus 2. I know that when I have the same equation, if I graph those equations, we would have overlapping lines. That's an example of infinitely many solutions. Infinitely many solutions. That's why I'm not a spelling teacher, guys. All right. Now, looks like I may be in Thursday. I have to see because my surgery was postponed, but I have some more tests to do, on Wednesday. So I'm going to go for a few more tests Wednesday. I may or may not be in Thursday. I'll let you know. But if not, I'll make sure I communicate with you guys. You guys communicate with me. I'm up here 11 o'clock at night. I didn't get any text messages or Mr. Plata, I didn't understand this or that. It's easy enough for me to post some solutions online. All right, so if that's what it's going to take, to get you guys through this time, then that's what we're going to have to do. All right, but we'll be in touch. Good luck, guys. See you soon.